So I'm Fedra Ekonomopoulou.
I'm Telesila Bristogianni. We are from TU Delft, Faculty of Architecture and the Built Environment.
And we have developed a research methodology for recycling glass waste via casting for components for the built environment.
This idea really started with a brick and the research for the crystal houses.
Where essentially that's where we discovered the potential of cast glass. It's volumetric, right? It's not 2D, it's strong. And in that facade, it was transparent and it was adhesively bonded. So we really started questioning, like, how can we make this more sustainable, more circular? And we really have a lot of volume here of glass. Why don't we use glass waste as the source material? It should be able to withstand more defects.
When we started looking into the recycling of glass, we realized all these daily products, glass products, that do not get recycled at this moment because of coatings, adhesives, colorants, or even logistical reasons. This is an example of medical vials recycled into a tile, which could be a facade panel. And from the way that we have placed the vials inside of the mold, you can still see the memory of the material of some daily products that used to be before it became a tile. And what is interesting in this example is that medical vials are most of the time rejected, either because they are considered medical waste, biohazard waste, or simply because they're made from borosilicate and there is not a mature collection and recycling system for borosilicate glass at the moment. But this is a glass that can be very heat resistant and chemically resistant, so it adds value in the product.
So this is one of my personal favorites. It's actually recycled oven doors from the oven at your own house. And similar to car glass or windshield glass, again, what you see here, this beautiful color pattern, is from the black enamel that is around the oven door. So this is a glass that is currently not recycled, right? It's discarded or is really heavily downcycled, but you can make really beautiful panels out of it. So this is from car windscreens. So, and what you see as the color here is essentially the enamel. So if you look at your windscreen, there is some black dots all around, which help you with the reflections when you drive. So these are then attached to the glass, right? It's a print, and now they have melted in and given this beautiful kind of color. So, and this is just recycling of art glass. So, and what you see here, all the different veils, it's how the glass, it's the memory of the glass as it was cast. So that's why we say it really gives a presence and a character. And it's essentially like old, let's say, vases you have at your home. And here it's borosilicate rods. So borosilicate glass is one of the most expensive glasses, is what we have in the ovenware, for example, or laboratory ware. And this is just recycled rods, but we can also show you how we can manipulate with the different factors during casting the resulting outcomes. So we have used a temperature where you can still see the memory of the pieces that we put in. So in essence, casting this is a bit like cooking. Depends on the temperature, depends on what you put as the flour, depends how you mix them. All these add to the result.
These ones over here are also art glass, and what is interesting in these two products is that they're made from the same glass. This glass, which looks like an artificial marble, has been processed at the lower temperatures so the glass crystallized. So that shows you that it's not only the glass composition, is what Fedra said, also the cooking schedule, the temperature that you're going to use can really change the molecular structure of glass. It can even give you different properties. One has transparency, the other one is maybe harder. So glass is not a transparent thing as many people conceive it. It has a lot of character and a lot of expressions. And in architecture, we think we have underexplored the concept of glass. We can do much more.
I would say that TRL right now is around 4. In the sense that we have validated it in laboratory environment, but we are still to apply this recycled glass in a real application.
There are still uncertainties regarding the data, so the strength or the properties of the glass, which we are now evaluating in the laboratory. But we also need the industry to take more risks with using waste recycled products in buildings. Well, we cannot afford for much longer to extract new materials and also to waste all the materials after the end of life of a building. So we really need to have a mentality shift towards using waste, normalize this, and use waste for products in architecture.
And they can be really beautiful. So it's also embracing, I would say, defects, embracing the peculiarities of glass or of any other recycled material, because it really becomes more present as a material.
There is a character of the glass because of all these contaminants and the waste that the colorants that used to be there that didn't allow the glass to be recycled in the first place, but then we transform it into added value in our components.